All right, so this is section 10.6. So I want to start by telling us the definition of a circle. We're going to go into more detail with circles, a lot more detail with circles in chapter 12. But I want to start with this just so it's in the back of our head. So a circle, the way we define it, is all points that are the same distance from a point called the center. So this idea of distance, the circles have to do with distance. Well, what do we call that distance for a circle? If we're on the circle, away from the center, what do we call the distance from the center to the circle? From the center to the circle? Yeah? Radius. The distance is the radius. And when we go into a little more detail, we'll talk about how the distance formula is related to the equation of a circle. All the way across the circle is, what do we call that? From one side of the circle through the center to the other side. Diameter, there we go. The diameter d equals, well, how is the diameter related to the radius? Double. Diameter equals 2 times the radius. All right, so let's talk about some parts. I'm going to draw a circle here. And I'm going to call this point at the center P. So we name this by the point at the center. So we would call this circle P. Or sometimes you just see a little symbol like this. So this means circle. And P is the center. So I'm going to draw in some pieces. The diameter goes from one side to the other through the center. So that's a diameter. The radius goes from the center, just from the center to the circle. So there's going to be a radius. And an angle between two radii is a central angle. All right, so we're good with our pieces. We're going to talk about pieces of circles, smaller pieces of circles also. An arc is a part of a circle. And what we're going to be interested in today is how we measure arcs. How we figure out how long an arc, or how big an arc is. We'll talk about how long they are as well. A semicircle is an arc. Well, how much of a circle is a semicircle? Half. Semicircle is a half a circle. A minor arc is smaller than a semicircle. And a major arc is larger than a semicircle. So I want to draw a picture, and we'll talk about how we name arcs. So we're good with this stuff. Semicircles, half a circle, minor arc, smaller than half a circle, major arc, bigger than half a circle. All right, so here's my circle. And I'm going to draw in a diameter. And I'll call that point P. And I'm going to call one end of the diameter point A, the other end of the diameter point B. Sorry, point C. Point B is going to be over here. So the way we would label a semicircle is I would say arc ABC. And this tells us start at point A, go through point B, and get to point C. Arc ABC is a semicircle. And we can tell because the endpoints are the endpoints of the diameter. Arc CAB, that tells us we start at point C, go through point A, and end at B. That is a major arc. So the letters tell us which direction to go around the circle, C, A to B. And arc AB is a minor arc. So we use 3 letters to name major arcs, usually, and we use 2 letters to name minor arcs. So this, because this is AB, it tells us we don't go through point C. We're not going around this direction. We go straight from A to B. And we use this little arc to name an arc. All right, let's look at an example. Here's my circle. I'm going to draw in some pieces here. And all we're doing in this example is naming some major and minor arcs. So I'm going to call this point A, point B, point E, point D, and that's point C. And let's name some minor arcs. So who can tell me the name of a minor arc? Yeah? AD would be a minor arc. So that goes from here to here, smaller than a semicircle. What's another minor arc? Yeah? AB is a minor arc. Smaller than a semicircle, less than half a circle. Let's name one more. Anybody else see a minor arc they want to name? BE is a minor arc. Those are some. We could name a few more. How about major arcs? Let's name some major arcs. So, who can name a major arc for us? I'll get us started. Let's start at point A. A major arc that starts at point A. Need to be bigger than a semicircle? A, What is it? ABD would work. Arc ABD. So we start at point A, go through point B, and end up all the way around here on point D. That's more than half a circle. How about another one? Another major arc. Someone name another one? AEB? Yeah. That would be a major arc. Start here, go more than halfway over to B. And we can name some more. We just have, major arcs just have to be bigger than half a circle. How about semicircle? Someone name a semicircle for us? Did you say B? ADE would be a semicircle because we end up on one side of the diameter. What would be another one? BED would be a semicircle. Start here, end up at the other side of the diameter. So those, we could name a couple more, but those would be semicircles. All right, we're going to be interested, other than naming arcs and deciding if they're major or minor, we want to know how we measure them. So let's talk about that. So the first way is going to be what we call arc measure. And arc measure has to do with angles. To measure a minor arc, the measure is the same as its central angle. To measure a major arc, (360° minus the measure of the minor arc that's associated with it. So let's take a look at it. Look at an example. This sounds more complicated than it really is. So I'm going to draw in a central angle, and I'm going to call this point A, this point B. The center of the circle is P, and I'm going to put a point over here, C. So this would be circle P. The measure of arc AB, and I'm going to say this angle is 70 degrees. The measure of arc AB is the same as the central angle. So to measure a minor arc, we just find the central angle that goes between the two radii that make it. The measure of arc ACB equals, well, here's ACB all the way around. Well, arc AB is the rest of the circle. That's what we call the minor arc. So the measure of arc ACB is 360 degrees, because 360 degrees all the way around the circle, and we're taking 70 of them out. So that would be 290 degrees. So that's what we mean. That's what this means. A semicircle measures, what's going to be the angle measure of half a circle? 180 degrees. So semicircles measure 180 degrees, half the circle. And we can add smaller arcs to get bigger arcs. so we can add pieces together. All right, so let's look at an example that has to do with arc measure. We're good with that idea. So I'm going to draw a picture here, a circle, and I'm going to put a diameter in here, and a couple of other radii. And I'm going to say this angle is 60 degrees, this angle is 20 degrees, center is O, this point's R, T, U, and S. So the measure of arc TU, and the little m means measure. So it's a measure of arc TU here. And this is circle O. What is it? 60 degrees. We just look at the central angle there. So the measure of arc TU is 60 degrees. How about the measure of arc TUR? So TUR. And TR is a diameter. So TUR would be 180. That's a semicircle. How about the measure of arc STU? So STU. And we can add smaller arcs to get bigger arcs. Now it's going to be 80. We just add these two together. And finally, how about measure of arc RU? So from here to here. That would be 120, because we know that all the way from R to T is 180. So that's going to be 180 minus 60. So we can deal with the measures of arcs just like we would expect. What would be the measure of arc SUR? Major arc. So from here around to here. What's that? I think you went the other direction. So how far is it from, what's the measure of arc TUR? 180. What's this one? 20. So altogether that would be 200. All right, and we could find some others there as well. All right, we good there? Okay, we're going to measure arcs in a different way as well. So one way that we're going to measure arcs has to do with the angle. The other way that we're going to measure arcs has to do with the length of the arc. So we need to remember about the circumference. We talked about this the other day. The circumference of a circle is kind of like talking about what part of a shape? What's the perimeter. It's like the perimeter. It's the distance around the outside. And we know that the circumference, we talked about this the other day, is pi times the diameter units, or the circumference is, well, 2 radii are a diameter, so I could say 2 pi r units. So the other way that we're going to measure arcs is with their length. So now we need to talk about arc length. And arc length, like the name suggests, has to do with length. Arc measure has to do with angles. Arc length has to do with length. Arc length is a fraction of the circumference. And what we're interested in is how far part way around the circle. So we want to know what the length is part way around the circle. Well, we're going to use our equation for the circumference to help us come up with the equation of a length of an arc. So the the length of arc AB is the angle measure. The measure of arc AB divided by 360 degrees times 2 pi r. This is the fraction of the circle that the arc takes up. It takes up so many degrees out of 360. So that measure of arc AB divided by 360 tells us what fraction of the circle that arc takes up. And we could also say that the measure, the length of arc AB is the measure of arc AB over 360. That's our fraction of our circle that the arc takes up, times pi d. And that's going to be in units. So when we're talking about arc length, we're talking about inches, meters, centimeters, something. So this measure of the arc in degrees divided by 360, that tells us what fraction of the circle the arc takes up. All right, so let's look at a couple of examples having to do with arc length. So there's going to be a diameter. I'm going to call that CD. And we'll say that distance is 9 centimeters. And we want to find the length of CD, arc CD. We could do this in a couple different ways. We could calculate, or we could think about it without calculating. How much of the circle does arc CD take up? If that central angle is 90 degrees, what is it, Andre? A fourth. 90 degrees is 1/4 of the circle. So the length from C to D is going to be 1/4 of the circumference. So the length of CD is going to be 1/4 pi times the diameter. And if we wanted to write an exact answer, or in terms of pi, this would be 9/4 pi centimeters. we just leave this written as a fraction. If we want an approximation, rounded to the 10th, we'd plug this in our calculator, 9 divided by 4 times pi, and I get about 7.1 centimeters. If we didn't see right away that 90 degrees was a fourth of the circle, we would say the length, if we were going to calculate, equals 90 divided by 360 times pi times 9. Well, a 90 divided by 360 is just 1/4. All right, questions? Okay, let's look at one more. Here's my picture. My radius is going to be 4 feet, and this arc is going to be 100 degrees. And we want to know, oh, and I'm going to put a point over here, T. We want to know the length of arc S, T, R. Well, the first thing we need to know is the measure, in the angle measure of arc STR. So we're looking at this arc around this side. There's STR. What's the angle measure of that arc? We know that arc SR, the minor arc, is 100 degrees. What's left for arc STR? 260. So I could say 360 minus 100 is 260. So the length is going to be 260 divided by 360. That tells us what fraction of the circle it takes up, times 2 times pi times 4. I'm using 2 pi r since we have the radius. Well, 260 divided by 360, if I reduce that fraction, that's 13/18 times 8 pi. 2 times 4 is 8. And I can reduce 13 times 8 over 18 is 52 ninths pi, if I wanted an exact answer. And that would be in feet. And I could plug that in my calculator and I get approximately 18.2 feet if we round to the 10th. And to get this 52 ninths, multiply 8 by 13 and then reduce the fraction that you get there. So this would be my answer in terms of pi. This would be my answer rounded to the 10th. All right, questions? So what we'll do next time is talk about how we find areas of portions of circles. Okay. Homework, page 654. 10 through 26 even, 30 through 42 even, 46, 48, 52, 54.